Here are the notes for section 8.2 in your book. You can read over the focus points, but we will hit all of those. So this is going to be really similar to what we already talked about in section 8.1. The main difference in section 8.1, they told us that the problems were from a normal distribution. Now we're going to talk about what to do if you don't know it's a normal distribution, but it has a large sample size. So kind of a general rule is if you don't know if the population is normal, that's okay if you use a large sample size. So if you look at the next problem, obviously they do have a large sample size. They have a sample size of 40. And this has to do with sunspots and how often sunspots were observed. So take time and read that problem. What's kind of nice about this problem, doing it in your calculator, is they've told you the sample mean. So they added up all these numbers and told you the sample mean of these 40 numbers. I'm going to highlight 40 also, is 47. Also, they tell you that the true standard deviation, they believe, is 35. All right, so what they're going to test is, it's thought for thousands of years the mean number of sunspots for a 4-week period was about 41. Sunspot activity above this may or may not be linked to climate change. Does the data indicate the mean sunspot activity during the Spanish colonial period was higher than 41? So we're going to run a test. Remember, the first thing you always want to do when you run a test is state the hypothesis. So your null hypothesis and your alternative. So your null hypothesis is just, hey, yeah, we think, we believe what the claim is 41. And then higher than 41, so we're going to do greater than. Okay, since we're given the true standard deviation, that tells us to use a z-test. And we're going to run that on our calculator. I did enter the data into a list. So when I do my z-test, I'm going to tell it I want it to use the data provided. And notice that they still have this means what's the hypothesis mean. So I'm going to change that to 41. The standard deviation that's given to us in the problem, and again, that is 35. And I've stored that in list 1, frequency 1, and I want to test a greater than. So we're going to go to that third one and hit calculate. I'll show you guys how to do this on your calculator if you don't feel like entering in that whole list. So you always want to write down the z value and the p value. So z is 1.09. The p value is 0.137. Okay. All right. So this p value is not small. Remember, if it's small, we're going to reject the null. So we're going to fail to reject the null. That's like saying, all right, maybe this is true. And we do not think this is true. So when I write my sentence, I do not think it's true that they're higher than 41. So here's a sentence, if you want to copy it down. There is not significant evidence the sunspots are higher than 41. See how that goes with my X? We're saying that that is not true. Okay, and I said I would show you guys how you could do this without typing all of that in your calculator. Since they gave you the stats, we go to z-test and we do stats instead, okay? 41, standard deviation still 35. Okay, the X bar value they tell you is 47.0. All right, I'll just leave it 47. N is 40, and again, greater than. Oops. And see, we get roughly the same answer. A little different because of rounding errors. All right, and here's more of the new part of this section. The second part of section 8.2 is what do we do if the true standard deviation is unknown, if that's not given to you? That's more real life. In many real world situations, we are not going to have an idea what the true standard deviation is. Can you still test the mean under these circumstances? And usually yes. So let's pay attention to the requirements. If we have a random variable x, we're going to use the sample mean and the sample standard deviation, okay? If you know for sure it's a normal distribution or you think it is a symmetric distribution, any sample size n will work. So you could use a sample size of 10. But if you cannot assume this, use a sample size greater than or equal to 30. So kind of from here on out, if we are doing our own project, if we just stick to this rule, you know that you're going to be okay. All right, you're going to see this test looks really familiar. It's almost the same as a z-test. Do you guys see the only difference is it's a t, and you're using the sample standard deviation. Degrees of freedom, if you used your yellow sheet, to find the answer to T, you would use the yellow sheet, but we are going to use our calculator. Same rules about p-value, same thing about interpreting. All of that is the same. The only difference is use a t-test if you're using your sample standard deviation. So here, what's the major difference? Well, first I said what's the same about them, and then the major difference is a z-test, they have to tell you the true standard deviation. A t-test, we don't know the true standard deviation, so we use the sample standard deviation, just like with confidence intervals. All right, for this example problem, we're going to talk about a drug that's treating leukemia, and all this data is for 21 patients, and it's the remission time in weeks, so 10 weeks, 7 weeks, 32 weeks, how long that their cancer was in remission. Instead of entering this in the calculator, they've given you the sample mean of these 21 numbers and the sample standard deviation, and they tell you assume it is mound-shaped and symmetric, so then that means, okay, it's fine if our sample size is only 21 instead of 30. So here's the question we're going to answer. Does the data indicate the mean remission time for this new drug is different from the 12.5 weeks, which was what they originally thought? A previous drug treatment was 12.5. So our null hypothesis is going to be, it still is 12.5 weeks. And since we use the word different either way, we're going to do not equal to 12.5 weeks. Okay, show calculation by hand. I'm not gonna make you do that. All right, find the t-value and p-value using a calculator. So make sure you let me know that you're using a t-test because of the S, okay? And it's really simple in your calculator. Stat, test, t-test. Oops, there's a glare. All right, so this time I'm going to input data. So our null hypothesis is 12.5. Oops, sorry, I said that wrong. Stats. Okay, our null hypothesis is 12.5. Our sample mean is 17.1. Sample standard deviation, see how it even has an S? It kind of gives you a clue you're in the right spot. And our sample size is 21, and we want to test not equals. It's as simple as that. So make sure you give the t-value and the p-value. So the t-value is 2.1. The p-value is 0.0. Oh, I'm going to round that to 48. Okay, but look at our alpha value. So our p-value is small, but this is something really important. So it's not small enough. It is not small enough. So we cannot reject the null, meaning we're going to say we think this could be true, and we're going to say this is not true. That's why I put an X by it. So conclusion sentence, and kind of answer this question. The new treatment is not significantly different from 12.5 weeks of remission. And then you can even say at the 0.01 level. That's it.